welcome to the Deep Dive.
Yeah.
So today, wow, we're looking at something really different for Mars. Forget waiting, centuries for terraforming. What if we could just, well, build a sky?
That is exactly the core idea in our source for this deep dive. It's this pretty fascinating proposal called a Phi-LNA Martian Sky Operating System. And our mission today is basically to unpack this. It's a huge concept, covers the philosophy, the tech, the ethics.
Building a sky from scratch.
Pretty much. Designing an atmosphere.
And the really striking thing right up front, the bit that grabs you, is this line. You don't wait for Mars to become habitable. You make the sky work for you first. That just completely flips the usual thinking, doesn't it?
It really does. It challenges that whole sort of slow, long-term planetary evolution model for terraforming. It's not about waiting generations. It's immediate, active intervention, you could say.
Active intervention. So control is the key word here.
Exactly. Control and speed. Think of it less like waiting for a forest to grow and more like, well, precision agriculture for a planet's atmosphere.
Yeah.
Giving us knobs to turn that we've never really imagined before on this scale.
Okay, let's get into this vision then. ASCNETM. The source calls it an exoatmospheric terraforming lattice. Bit of a mouthful.
It is, but basically picture a kind of synthetic stratosphere floating kilometers above the Martian surface, and they frame it as step one. The first thing you do...
Step one is build a sky.
Okay. And the source really pushes the immediate benefits. It's not just a concept. It's designed for rapid deployment. So it generates warmth locally, right away, shields from radiation, critical stuff, and it lets micro-ecosystems get started much, much faster.
How much faster are we talking?
Well, they claim it's fast, modular, reversible, and precision-controlled, which is, the polar opposite of waiting maybe millennia for co-Euro to build up a greenhouse effect.
Right. So instead of a global slow change, it's targeted.
Exactly. You deploy it where you need it. Over habitats, maybe down in Valles Marineris or future farming areas. Think of it like a giant high-tech climate bubble, but way bigger and more sophisticated than just a dome on the ground.
A kilometers-high climate bubble.
Yeah.
Okay, the big question then is how? How on Mars do you build that? What are the actual, nuts and bolts?
Right. The source breaks down the core architecture into 5 main parts.
Okay, let's hear them.
First up, the levitation grid units, LGUs for short. These are described as these triangular fractal pattern things, ultra light, made of a graphene aerogel composite.
Graphene aerogel. Okay, light, but how do they stay up? Kilometers up.
Well, 3 methods working together, apparently. There's electrostatic repulsion, then low-gravity lift using helium or hydrogen, and the really wild one, magneto-aerodynamic suspension, using superconductors anchored on the ground to sort of push them up.
Superconductors on Mars keeping the sky floating. That's ambitious.
Definitely ambitious. And you asked about stability. The source suggests redundancy. If one system has issues, the others compensate. It's designed to degrade gracefully, not just, fall out of the sky.
Okay, graceful degradation. That's reassuring. What's next?
Next layer. Radiation shielding membranes. Think multi-layered nanofabrics. Their job is to handle all the nasty stuff coming from space UV, cosmic rays, solar flares, even dust particles during storms.
How do they manage that? Just block it?
Not just block, absorb, deflect, redistribute. And they have embedded smart crystals. These crystals can actually change the membrane's transparency and control how much energy flows through.
Like a planet-sized transition lens?
Kind of. A smart window for a whole region of Mars. It needs to be adaptable.
Oh, adaptable, right. Decentralized, too, you'd assume, to avoid single points of failure.
The source implies exactly that, a very networked, resilient system. Then we have the infrasolar reflectors. These basically capture sunlight and bounce it down, diffusing it.
For warmth, I guess. Melting ice?
Yes, warming habitats, melting permafrost. But also for more subtle things, like creating artificial sunrises and sunsets.
Artificial sunsets? Why?
For plant circadian rhythms. And maybe for human morale, too. We'll get to that. Plus, they can concentrate heat to create small updrafts, sort of steering the air locally.
Wow. Okay, steering the air with light. What else is up there?
Number 4. Atmospheric seeders. These are like little suspended labs, photochemical labs floating in the lattice. They generate trace gases, water vapor, methane, even oxygen.
How? Where'd they get the materials?
Through things like electrolysis of water ice, catalysis, or processing the CO that's already there in the Martian atmosphere, in situ resource utilization. Their job is to seed the air below, creating little pockets, microenvironments, and domes or valleys that are more breathable.
Localized air factories, got it. And number 5, You mentioned a brain.
Right, the neuromorphic AI command cloud. This is the real operating system part. It's described as a decentralized consciousness managing the whole
A
mesh.
conscious.
Well, maybe consciousness is a strong word, but a highly adaptive AI network. It reacts to dust storms, temperature changes, human needs, all in real time. It uses quantum weather simulations for predictions. And this is where it gets really interesting. It interfaces emotionally and visually with the colonists.
Emotionally. How does an AI interface emotionally with people about the sky?
They call it Sky UX, Sky User Experience.
Sci-UX. Okay. Elaborate on that one.
The idea, as the source presents it, is psychological support, making this alien place feel less alien. The AI would actively manage the visual display of the sky clouds, colors, maybe even auroras, to create a sense of comfort, familiarity, reduce stress.
So it's not just functional, it's aesthetic and psychological.
Exactly. It acknowledges that a familiar sky is maybe more fundamental to our well-being than we realize. Designing that involves deep understanding of psychology, biofeedback. It's complex.
Hugely complex. So moving beyond the structure, let's talk functionality. What does this whole system enable on Mars?
Okay, the key functions, we've touched on some. Creating those localized greenhouse zones, valles marineris, crater bases, colonies, that's huge. Diffusing the harsh sunlight into usable warmth without the dangerous radiation, essential for long-term living.
And supporting early life support, right?
Yes,
For the
yeah.
biodomes.
Absolutely. Regulating light and gases precisely for algae farms, early plant growth. And another big one, enabling wireless power transmission, beaming power down from orbital solar arrays directly through the lattice. That could solve a lot of energy problems.
Wireless power from orbit. That's a game changer in itself. But you mentioned the psychological angle again.
Yes, the psychological sky simulation. This is where the source gets really profound, I think.
Go on. What does that entail beyond just nice visual?
It's about simulating the full Earth experience almost. Blue skies, yes, but also realistic clouds, weather patterns, maybe even simulated rain effects visually. Full day-night cycles tuned to human needs, all designed to keep colonists mentally healthy, maintain their circadian rhythms.
Wow. It really makes you stop and think, doesn't it?
Yeah.
How much do we rely on just seeing a blue sky?
We take it completely for granted. Imagine being somewhere it doesn't exist and someone offers to build you one. How vital would that feel?
Very vital, I suspect. Which brings us to the philosophy behind this whole thing. The source calls ASCETM incremental, ethical, and intelligent. What's the thinking there?
This ties into the bigger picture of responsible planetary engineering. It's a really thoughtful approach outlined here. Key point. It operates above the surface. Zero permanent alteration to the Martian crust itself.
Zero permanent alteration. That feels significant.
It's huge. It's just stewardship, not just conquest. Like we're building with an undo button in mind, which is rare for projects this ambitious. It's also adaptive in scale. You can start small, a 2-kilometer radar shield for a first base, and potentially scale up to a 1,000-kilometer regional net later.
Incremental. Makes sense. How is it actually built, though? Launching all that from Earth seems impossible.
The idea is swarms of self-assembling bots, launched from orbit maybe, or even constructed using Martian resources, ISRU again, minimizing the Earth payload dependency.
Self-assembling bot swarms building an artificial sky.
Yeah.
And the reversibility, how real is that?
Well, the components are designed to be dismantled or repurposed without leaving permanent scars. Biocontainment is also built in. It's about managing our footprint by design. It reflects this idea of planetary intelligence, being smart about how we expand.
Planetary intelligence, I like that. So, looking even further ahead, does the source mention future upgrades? What comes after the initial sky lattice?
Oh, yeah. It gets even more sci-fi. They talk about potential sky cities.
Hanging from the mesh.
Exactly. Habitation structures suspended directly from the lattice for exploration, maybe even atmospheric cloud farming. Then there's volcano-aided jet columns, tapping Mars's geothermal heat from volcanoes to help warm the upper atmosphere.
Using Mars's own heat.
And finally, something called memory sky arrays.
Yeah.
Essentially, giant digital archives of Earth-sky phenomena. So the AI could simulate specific Earth sunsets, cloud formations, maybe even rainbows drawn from this vast library, keeping that connection to home alive.
Sky cities, volcano jets, memory skies. It's quite a vision of the future Martian experience.
Yeah.
So to wrap things up, the core message from this ACKM source seems to be proactive creation.
That's a good way to put it. The source summary says, it's the operating system of the future Martian sky, intelligent, alive, and co-evolving with humanity's expansion beyond Earth. No waiting, no dreaming, just building.
It's building. Powerful statement.
It really is. And it leaves us with some deep questions, I think. What does it truly mean to install an operating system on a planet's atmosphere? To actively design a sky, that's immense power and immense responsibility, even if it's designed to be reversible. We shift from visitors to architects.
Planetary architects, that's definitely something to mull over.
Hmm.
And maybe a final thought for you listening. If you were there, under that Martian sky operating system, what kind of sky would you want designed for you? What does home look like when you can program the sky itself?